X squared minus 14x plus 16 equals 0, and it wants me to find the solutions. So the solutions are the roots, are the x-intercepts, are the zeros, right? All different ways to say the same thing. So this is what we've been working on, is how do we find the solutions or the roots in this situation? Well, this is a quadratic equation. We would like to get x by itself, but we can't get x by itself because I have an x to the second and x to the first. They don't combine. So what I need to do then is factor this. If I can make this be two things multiplied together to be 0, then I'll be in business. So this is a trinomial, ax squared plus bx plus c. So I can do the a times c method. Here, a times c is 16. What multiplies to be 16? 1 times 16. 2 times 8. 3 doesn't work. 4 times 4. That's all my options.
And nothing?
So what multiplies to be 16 but combines to be negative 14?
None of those.
None of those. Okay? None of those.
We never did this.
Well, yeah, this is going to be new, right? What happens if I can't factor it because, well, we could keep graphing it by finding the axis of symmetry, but we're not looking for the axis of symmetry. We're looking specifically for the solutions, the x-intercepts, the roots, the zeros. So, what we have is we are going to learn today one way that we can find the solutions. The way that you are learning today. Okay, let me say that again. You're going to learn a new way today to find the solutions when it doesn't factor. Right? So, in total, we're going to have 3 ways we can find solutions. The first one is factor it, and then set them equal to 0. The one you're going to learn today is one thing we can do when it doesn't factor. But this is the harder one of the two. Right? Most people don't choose to do this one again. But it's the one we got to learn first.
What's the third one?
We'll learn it Monday. Okay?
So tomorrow we're going to do additional practice and the quiz will be like relearning. So it's like we do the same thing like every week and it gets harder, but it's cool.
So then Monday will be learning the third way. So today, this process we're going through is called completing the square. Completing the square.
Yeah.
Maybe you have.
Nope.
I didn't hear you haven't.
He's lying. No, he's lying.
So here's how we're going to complete the square. We're going to start by kind of copying our problem down. But we don't want to put the plus 16 yet. Okay? So you see I've got x squared minus 14x. Then we're going to be adding something.
No, okay, never mind. I didn't think.
You gonna teach it? You gonna teach the lesson?
I was fine then.
How do we know it's plug in?
That's what we're fixing to go over. Okay, all right, is everybody ready? Everybody got this so far? Now, in order to complete the square, we always want our a term to be 1. If it's not 1, we need to divide by that number to make our a term 1. I think everything we're going to do today is going to give us an a term of 1. They're going to be really nice. Everybody see that? So the first thing I'm looking for, number 1, a term is 1.
review with this?
Now we're going to look at the B term. So once we've made the A term 1, second, we want to take the B term and we're going to do two things. I want you to half it and square it. Half it and square it. So what's my B term here? 14. Half that number. What's half of 14? 7. Square it. 49.
I'm sorry, I was just, I'm not talking anymore.
So whatever number we get, once we've halved B and squared it, we want to add that number to both sides of my equation. So it's going to be a plus 49 here. And to keep our equation balanced, we have to add 49 to the other side as well.
How did Kelly know that?
So now, this is going to be something that we can factor very nicely. Right? This part will be very nice to factor. But this 16 is a thorn in my side. So I want to get the 16 over to the other side. So we would subtract 16. So now what I have is x squared minus 14x plus 49 equals 49 minus 16 is 33. Well, 0 plus 49 is 49. And then 49 minus 16 is 33. I realize this kind of looks ugly. I did three things at once.
Why did we do 0 plus 49?
Because we added 49 here on the left side. So to keep our equation balanced, anything we do to one side, we have to do to the other. So I added 49 to both sides. Then I wanted to get rid of this 16. So I had to subtract 16 from both sides. Keeps it balanced. Is everybody good here? Now, this is going to be something that factors very nicely when we complete the square. So, A times C is 49. What multiplies to be 49 but combines to be negative 14? 7 and 7. So this is going to factor to be x minus 7 times x minus 7. Is everybody okay if I skip the rewriting the B term? Yes, this is a special case. That's why I skipped all these steps to get to here. Every time we complete the square, these are going to be the same thing. The parentheses are going to match. So I'm stopping right here for a reason, because I want to explain something. What have we been doing? We've been factoring, and I've had two things multiply together to be 0. But what do you know if you multiply two things together and get 0? You know at least one of them has to be 0. Here I'm multiplying two things together to get 33. So do you really know anything? No, because these could be 1 and 33, could be 3 and 11, right? So I can't take each one of these and set it equal to 33. Does everybody understand that? Why you can't? Because it's not a 0. The only time you can do that is when it's a 0. But what we can do is, what is another way we can write this? X minus 7 times x minus 7. That's the same thing as x minus 7 squared equals 33.
We're literally just learning the same thing and just adding steps.
Math. That's called math. Does everybody follow my steps to here? I'm going to go to a new screen so I can make this look a little cleaner, because I know this is really ugly right here.
Shut up.
So what I have is x minus 7 squared equals 33. Now my big problem with solving the equation before was I had two x's. One of them was x to the second, one of them was x to the first. So I couldn't get the x by itself. How many x's do I have in my equation now? 1. So now I can go through the whole process of solving this equation. So how do we solve an equation? We want to get x by itself. And I want to undo everything around x to get it by itself. So why is x not by itself?
It's being
Subtracted by 7, and it's being squared. This is new. I haven't worked any problems like this with you this year, where x is being squared. So which one of those do I get rid of first? Subtracting 7 or squaring it?
Subtracting 7.
No. Squared. Remember my rule that works 99% of the time. Get rid of the thing that's farthest away from the x first. So what's farthest away? Subtracting 7 or squaring it? This is outside parentheses. This is inside with the x. So this is farther away. So I want to undo squaring something.
I was thinking of this.
So what's the opposite of squaring a number?
Square root.
Taking the square root of a number. So I can undo squaring by taking a square root. Square root, square root.
We had some of this on our factoring page.
There was a little bit of it in there. And we did a little bit of square root stuff I did with y'all right before Christmas, I think. So if I square root something that's being squared, those cancel. That's the whole point of doing that. And I'm left with x minus 7 on the left. Okay, now on the right side, we have the square root of 33. So what number times itself is 33? It's a real ugly number. Okay? So it doesn't simplify. We're going to leave it as the square root of 33. We leave it just like that.
Bring that down.
Mm-hmm.
Okay, when are we going to get the answer?
When I get x by itself. Now.
No wonder no one else does this.
Now. One more rule we got to add. We chose to take a square root of both sides. Whenever you choose to take a square root, you must always account for the positive or the negative possibility. Here's what that means. So let me just explain it in a different. If I had the number 9 and I took a square root of it, what number times itself is 9?
3.
So is negative 3. Right? What is 3 times 3? 9. What is negative 3 times negative 3? 9. So the square root of 9 could be 3. Or it could be negative 3. We don't know which one it is because both could work. So here, when I choose to take the square root of 33, I'm saying what number times itself is 33? Well, it could be the positive of whatever that number is, or it could be the negative of whatever that number is. This is how we say it shorthand, plus or minus the square root of 33.
Why does that matter, though, if they both equal the same thing?
Because our answer could be one or the other. Just like when I had two things multiplied to be 0, either the first thing could be 0 or the second thing could be 0.
So you only get one answer, but you have to include the or this, like, in your answer.
Because we don't know which one it is. It could be positive radical 33 or negative radical 33.
In this case, it's just positive or negative, right?
Just like how before I was setting both things equal to 0. Now it could be positive radical 33. Or it could be negative radical 33. I don't know which one it is. Okay. Is everybody good to hear? Now, is x by itself? No. Remember, we got rid of squaring it. So why is the x not by itself? Subtracted by 7. So we're going to add 7 to both sides. On the left, that cancels. Beautiful. On the right? Meh. This is underneath a radical. This is not underneath a radical. I can't combine them. They're not like terms. One's under a radical, one is not. So I'm going to move the 7 out in front, plus or minus the square root of 33.
So that's the answer.
So remember, what am I finding? I'm finding the solutions, or the roots. The x-intercepts. How many x-intercepts does the parabola normally have? 2. What are the 2 x-intercepts here?
7 or 5.
It's 7 plus
Or minus.
radical 33,
What?
or it's 7 minus
Wait. So
radical 33.
we would never take the 33 out because it's an ugly.
You don't know, no. Because you're going to be given a decimal, and you have to round it. And we don't round because we need an exact solution. So what if you had to graph it? It's not going to be very pretty, right? That x-intercept's not going to be pretty. So we're moving away from graphing them to now we're just finding the solution. When I make you graph the x-intercepts, I'm going to give you pretty ones most of the time. If not, just going to have to estimate. This is just a roundabout number. So what I want us to do, I'm telling you exactly where these x-intercepts are. Let's go on our graphing calculator. Let's click y equals. And let's put in our original equation, which was x squared minus 14x plus 16. Right, that was the very original equation. X squared minus 14x plus 16.
It is very, very
Graph it.
Oh, it's just straight line.
Yeah, so we can't see all of it. Does everybody have it graphed? So let's click zoom. 3. Enter.
Okay, what is that?
Oh, look.
Oh, no.
Does everybody have their graph up? You did it one too many times. You zoomed out twice. So just like, did you zoom out twice? Zoom 3, enter.
So this right here is saying that it would go
I
over.
didn't hit 3. Zoom 6. That's what I missed. Sorry, let me get I need to zoom out. Zoom. 3. Enter.
Coach just pulled some voodoo magic. He just went.
Alright, is everybody here? Everybody have the graph where they can see both x-intercepts? I couldn't see but one x-intercept on there. How many times have you done it? You messed up. You don't have x squared. You have x2 squared. See, now I can see it's, no, it should be a parabola. It's an x squared. Is everybody good? Now, remember the day we found the x-intercepts by using calc. So we're going to click second, trace. We're going to find the 0. So you're going to go to 2 and click enter. Okay, let's find the one that's farther to the left first. Let's find that x-intercept. So pick a point that's, you can click enter right where you started. Pick a point that's left of the leftmost x-intercept. Then you're going to tab to the right. Click enter. Don't need to go do this on the. Don't need to go do this on my calculator so y'all can watch me. Y'all all lost.
I don't have the lines in the back of
I feel like I understand it.
mine. Mine is just clear.
Hold on.
I don't understand.
Hold on. So the stuff I'm showing you now is me trying to help you make sense of it. This is not part of the problem anymore. This is me trying to tie it all in. Make math make sense. Okay, so here we go. I've got y equals. So my equation was x squared minus 14x. Is that right? Plus 16. And then we graphed it. I'm gonna get the same zoom you guys have. So zoom 6. And then I need to click zoom 3, enter. This is what everybody should be seeing. All right, it's hopefully here. So if I'm wanting to find, you see how there's 2 x-intercepts, 2 roots. I want to find the first one. So the one that's farther left, that's this one here. So I'm going to click second, trace. And then I'm going to go down and click the 0. Everybody with me? Now it says pick any point that's too far left of this x-intercept. So the x-intercept is here. I'm too far left. So I click enter right where I started. Now I want to go too far right for that x-intercept. So I'm going to go right until I go past it. All right, I'm definitely past it now. Click enter. Then it tells me to give my best guess. So I'm going to go here, click enter, and then it'll tell me where that x-intercept is. But again, this is rounded. You can tell by how ugly that decimal is. This is not an exact answer. This says my first x-intercept is at 1.25543374. Does everybody see that number? Now, what did we have as the smaller x-intercept? We had 7 minus radical 33. Right, but the smaller one is minus. So 7 minus radical 33. Right, that was my answer.
Ain't no way, bro. Wait, so you
I'm finding the x-intercept. But I'm finding it as an exact answer, not as a rounded answer. 1.255437. See, they had to round because they would keep going. But mine gives more. Well, guess what? Mine's rounded too. Because this number is an irrational number that is never going to repeat and it's never going to terminate. It's an irrational number. So this is the exact answer. These are rounded answers.
Isn't it crazy how like something will go on forever and it'll never repeat?
Yes.
So many different things. That is wild for sure.
So,
I know I'm losing some of y'all at this point. That some of y'all don't care about this.
It's a
stuff.
lot of information.
It is, but I'm trying my best to. I don't want to just show you how to do something and not explain it.
I'm trying to make sense of it.
That's crazy.
It's like I'm getting a little bit of it, but I'm not getting all of it. But I know how to explain things and make me understand all of it.
I'm just proving that's the x-intercept, right? That's really what I'm doing. Our answer, everything that I'm teaching you today that is required is what was on here. What was on the iPad. That's our process. That's completing the square. That's what we're trying to do. Is we're finding the x-intercepts. And here they are. Exactly.
So that's how we read top line range.
Yes.
Let's put in both of those.
Yes. It'll make you do it separated by a comma. Just like it did
So we
before.
got like 7 plus square 33 comma 7 minus.
Yes.
Can you help me out and support over here?
Try to do it on our own.
The only option I have right now is to complete the square. So to complete the square, we need the a term to be 1. It is. We're going to take our b term, which is 10, half it, 5, square it, 25. That's the number I want to add to both sides. So I've got x squared plus 10x
Oh, God.
plus 25 minus 9 equals 25. You see how I've added 25 to both sides?
I messed up. I had 9.
Yeah.
Well, that's okay. As long as you still did this, you're okay. Add 25 to both sides.
As long as you have it.
Then, I want this plus 9 to go to the other side.
Is it?
So that's going to leave me with x squared plus 10x plus 25 equals 34.
Okay, I see. Four numbers.
Any questions on those steps? Yep.
What if we?
Any questions to this point? Anything else? Now what's on the left? This is a trinomial. ax squared plus bx plus c. If I do a times c, I get 25. What multiplies to be 25, 1 times 25 and 5 times 5, combines to be 10. Well, the only thing that can combine to be 10 would be 5x and 5x. So I've got x squared plus 5x plus 5x plus 25 equals 34. Questions on that step? That's my normal factoring step. That's what we went over for 3 weeks. Now I'm going to group. I've got 4 terms we group. The GCF of the first 2 is x. That leaves me with x plus 5. GCF of the last 2 is 5. That leaves me with x plus 5.
I had I did all the steps right just at the very beginning instead of adding 25. I just added 9 and I didn't get 34. I just had 9.
You just fix that to be a 34 over there. That's okay.
I didn't do the bottom 2.
That's okay. I didn't do these last time either.
I just put x plus 5 in the second.
That's fine. That's what it's going to be. But some people got confused when I was walking around. They wouldn't know how I got from here to the last one. And if you don't know how to just factor it by looking, this is the way I taught you to factor. So I'm just going to show you that. Okay? But it's the same process.
You sort of confused me after you wrote that down. I was like, uh-oh.
No, because now, do the parentheses match? Yes. So what's in front of the parentheses? X plus 5 times the matching parenthesis. X plus 5.
Wait, wouldn't it be 3? X plus 5 to the third?
No. It's always just the matching parenthesis. I don't have time to explain it right now. But it's just one of the matching parentheses, always. So what is x plus 5 times x plus 5? It's x plus 5 squared equals 34.
Take the square root of it.
Now, I've rewritten. I've taken this whole mumbo jumbo, I've rewritten it with a single x. So now I can solve for that x. I know how to get x by itself, so that's what we're going to do. So what's farthest away is the being squared. How can I get rid of squaring a number? Take a square root of both sides. Square root of a square cancels.
You just bring that square 34 down.
Anytime I choose to take a square root, there's always 2 possibilities. I have to account for the plus or minus radical 34.
Subtract 5 from both sides.
Subtract 5 from both sides.
So it should be.
So I've got, I'm gonna write that down up here.
Yeah.
Plus or minus?
Well, some people don't.
So subtract 5. So x equals, it's a negative 5 plus or minus the square root of 34. So that means I have 2 solutions. Negative 5 plus radical 34 or negative 5 minus
Sorry.
radical 34.
know the
When we go
negative
put
5
it
is
in the
negative 5.
answers,
But we
we we have to put a plus?
Radical is a positive negative.
We don't have to put the plus in, do we?
Yes,
When we go to put it in.
because these are two different terms.
And
They have to
we
be
go like it's multiplying together?
separated by, yeah, be like it's multiplying if you don't.
Okay.
Now, you could write this one, if I flip them, you could do radical 34 minus 5, and you wouldn't have to have the plus sign. But I always just put a number in front of my plus or minus, because I realize if I put it after, people get more confused. I always put my number in front of the plus or minus.
How would we write that tomorrow? Any additional practice like that right there?
Just like
I wish we could just do it like the first.
There'll be a square root button in the toolbar that you have to click.